and I'm a PhD student at Jönköping University, Sweden. Today, on behalf of our research team, I'm going to present our paper, and the title is Conceptual Framework for Blockchain and AI-driven Digital Twins for Predictive Operation and Maintenance, with a mouthful title. And but as opposed to the other studies in this session, I'm not going to dive that deep into blockchain implementation details or other technologies. I'm just presenting an overview of the integration possibility for these technologies or disruptive technologies. Yes, today I'm going to talk a little bit about the background and the advantages of each individual components of the framework: digital twin, predictive maintenance, and blockchain. And IDF0 as the method we have used in this study. And the functional analysis results, overview of the functional analysis and the components, decomposed components. And also at the end we will have the visualized proposed framework and a little bit of discussion. So managing assets in the built environment, especially in the operation and maintenance field, is a kind of challenging and complex kind of task. Of course, existing tools and systems such as building automation systems and computerized maintenance management systems have made remarkable improvements. Nevertheless, there are actually many recent studies where they have highlighted the need for an integrated platform that can manage scattered data and support various maintenance activities. So this is the starting point of our study. So digital twins are very powerful tools for understanding, monitoring, and optimizing the physical assets in a virtual environment, leading to improved performance, efficiency, and decision making. Through real-time data integration, digital twins are seen as a promising solution for enhancing collaboration and information sharing across the project lifecycle, and from design to operation and maintenance. So DTs also provide the ground for integration of IoT devices and sensors, different technologies like blockchain and AI and machine learning algorithms. So yes, traditionally in the prevailing approach for maintenance in the building facilities is kind of reactive or corrective maintenance, where when some failure happens, then the facility manager will take an action to fix that. And of course, this is a kind of inefficient way. There would be unexpected downtime and repair cost, and also the reduced lifespan of the asset. So as opposed to this approach, predictive maintenance is identified as an efficient strategy that can significantly reduce operation and maintenance cost by using data-driven procedures to predict asset behavior and identify abnormal behavior before a breakdown occurs. Predictive maintenance through condition monitoring, through fault detection and failure prognostics can also lead to maintenance schedule optimization as well. And blockchain, of course, this session is about, actually offers several significant benefits for smart building facility management. It ensures data security and integrity through cryptographic techniques, enhancing transparency and trust among the stakeholders. It's also by automating the process and utilizing smart contracts, blockchain streamlines the operation and reduce manual efforts. So this technology also facilitates collaboration among the stakeholders and fosters a more efficient exchange of information and the resources. And it also enables the cost saving through optimized resource allocations. And the method we used here to develop our framework is, as I said, IDEF or integration definition method for function modeling. IDEF0 function modeling provides a structured approach to analyze and model complex system in a visual and easily understandable way. Also, it offers hierarchical decomposition and data flow representation of the functions. And by breaking down the system into its constituent functions, IDEF0 allows for a clear understanding of the system purpose and the relation between different function and some sub-functions. So in this study, we have configured the IDEF0 model and like components by exploring the recent literature and incorporating expert opinions from 2 studies we conducted prior to and aligned with this study. And this is how typically a function looks like in IDEF0 modeling. So we have input and output from the sides, and of course the title, the function, the activity is going to be performed is in the middle of the box, and control, which is the decision logic, and dependencies from above, and from the bottom we have mechanisms and calls for or referring to the other functions. So this is actually the overarching function. Conventionally, it's like identified by A0, which is the main activity. So the overall purpose of the framework is to develop a smart and secure asset maintenance system. So for this purpose, we have as-built models, maintenance plans, and IT raw data from the sensors. And the desired output is like real-time performance optimization, fault detection, and notification, and safe and the decentralized data handling. And the controls or the decision logic is actually a function of or depends on the stakeholder needs and the budget, available budget, and many other things. I'm not going to go through all the factors because of time constraint. And the mechanisms are different technologies and the tools available for this. So, and the next step, this overarching function will be broken down to 4 sub-functions, as you can see. So we need to equip the physical entity first, and like with the IoT sensors, and then the digital twin is built up, or digital counterpart that the result would be the digital twin. Then the digital twin is integrated by blockchain in the third function, and finally an interface, user interface, will allow the stakeholders to interact with the whole system. And again, the next step, A2 and A3, these 2 functions would be broken down again to the one A02 to 4 child functions, we say. So for this purpose, to actually build up the digital twin, we need to acquire data and pre-process the data somehow. And this data would be, we will feed the next function, which is develop method at an algorithm with this data, and conduct analysis and control them. So this is actually where the predictive maintenance is happening, and our research group is now focusing on this part mostly. So, and then A03, the integration of blockchain, is broken down again to 3 functions. So we have to organize the data and the models. So to classify the data, to recognize which data needs to be on-chain and which off-chain, and accordingly these two functions would be performed. So the input for this like child function is like building digital twin, and we will have the blockchain-based DT, and of course the sorted data off-chain and on-chain. Putting all these functions and sub-functions together in one frame, this is what our proposed framework looks like. So as you can see, here is each dashed square is like kind of a module of this framework. We have the physical asset equipped with the IoT sensors and things. The digital twin, which is interacting in real time and dynamically with the physical asset. And then all the data we have, static and dynamic data, would be transferred to cloud storage, where the AI algorithms work and do the prediction and things. And then the identified data or classified as on-chain will go on-chain, and here is the user interface. We have to actually interact with all the modules based on their access level and permission defined for them. So that's all for me. Thank you.